Hi guys, and in this video we're going to look at the Unit 4 checkup from this half term. Now, again, kind of similar to the other ones, you should have had this back marked from your teachers, and then you should have what went well and then an action point, which will be one of these TR Maths videos for you to go and watch. Okay, so make sure you, once you've marked this, that you go and watch those, you make your notes, and you complete your dirt like you're supposed to. Okay, but apart from that, we're going to walk through each question here for you to do corrections. So for the first one, we got resolving forces. Diagram shows 4 forces acting on the point A in a horizontal plane. So you see what we got here. Now, I'm not going to read the next bit, okay? I see straight away that I've got forces at angles here. So I'm going to split those into their components straight away. So for example, this one, okay, this would be Q cos of 30, because it's adjacent, and then this one would be Q sine of 30. Okay, and I could do a similar thing for the P. Okay, going across is going to be P cos of theta. Sorry, 45, not 30. And then my vertical component is going to be P sine of 45. Okay, so I'm going to do that straight away because then it makes my answers a little bit easier when I get into finding which components I need. So given that the forces are in equilibrium, so it tells me this point, this equilibrium, which means that the forces vertically going up and down should be equal, and the forces going horizontally to left and right should be equal. Calculate value for P and Q, give your answer correct to one decimal place. So clearly I've got P and Q working in both directions here. So when I resolve vertically and when I resolve horizontally, I'm going to have P and Q in both expressions, which means I'm probably going to have some simultaneous equations. So the first thing I'm going to do, okay, is I'm going to resolve vertically. Okay, you could do horizontally first, doesn't matter. Okay, I just normally start with vertically. So that means all the forces going up should equal all the forces going down. Okay, so going up, I've got P sine of 45, and I've also got Q sine of 30. Going down, I've got 12. Okay, now I can see 45 and 30, which means I can use my exact values and stuff like that a little bit here. Okay, sine 45 I use in my calculator is root 2 over 2 p plus, and then sine of 30 is a half, so I get a half of q equals 12. Now, obviously, I got two unknowns there. I'm going to do the same with horizontally, but these are a little bit easier to spot. Okay, if it was like sine of 20, I would just leave it as sine 20, but because it's one of my values that we're used to seeing, like 30, 60, and 45, okay, I've used my exact value. So next one we do is we're going to resolve horizontally. Okay, so that means everything going to the left equals going everything to the right. So going to the right, I've got 8 for the 8 newtons. This one's, don't forget that. Plus, I've got the component of Q, so Q cos of 30. Okay, going to the left, okay, I've got P cos of 45. Okay, now I'm going to do the same thing again. I'm going to change those into their exact values. This is root 3 over 2 Q, and then P cos is root 2 over 2 P. Okay, now clearly we can see that we've got two simultaneous equations. So what I'm going to do is I'm going to rearrange this second one so it looks a little bit more like the one above. So I'm going to take the P and Q both onto one side, and if I do that, I get 8 is root 2 over 2p minus root 3 over 2q. That's my equation 2. Now what I'm going to do look, if I look at these two, the p's have the same coefficient, which means I don't need to times anything or do anything like that. I can simply, they're the same sign, so I'm going to subtract. So I'm going to do number 1, take away number 2. If I do that, I got 12 take away 8, which is going to leave me with 4. Okay, and then I'm going to have a half of q, so I've got a half of q, minus, so plus root 3 over 2q. Okay, I'm going to do my kind of factorizing bits here. That means q, and I've got a half plus root 3 over 2. I'm going to divide by that bracket. Is going to give me q is, the exact value it gives me is minus 4 plus 4 root 3. Okay, obviously I'm going to use it, that's why I've written that, but that is, as one decimal place, is 2.9 newtons. Now, to find P, I'm simply going to substitute it back into 1 or 2. So if I sub it into 1, okay, I'm going to use my exact value. it's going to give me P as 14.9 newtons. There's my two values, okay? Now all I've done there is I've subbed my exact value of Q here, so minus 4 plus 4 root 3, into this equation here, and I've just rearranged and solved, okay? Just using my calculator and exact values. Okay, so for the next one, question 2, we've got a particle of mass m is sliding down a smooth slope. So I don't need to worry about friction here, angled at 30 degrees. So what I'm going to do first, I should have a very generic kind of diagram to draw here. Okay, there's my 30 degrees, there's my box, it's got a mass of m, so it's got mg going down. It should have a resultant force going up. Now I'm going to keep reading, okay? The normal reaction, which is R, okay, of the particle is 5. So they actually tell me this is 5 going that way, okay? Now, again, if this angle here is 30, then we should remember that this angle here is also 30. Okay, now part A simply wants me to calculate the mass of m of the particle. Now, I've got two scenarios to do here. Okay, I'm either going to resolve perpendicular to the plane, so up and down, or I'm going to do parallel to the plane, so what's sliding up and down the slope. Okay, so in this case, I know 5 is going up, so I can use the component of the weight going down. So what I'm going to do is I'm going to resolve perpendicular. To plane. So is everything going up off the plane, which is 5, should equal everything going down. Now going down, I've got mg cos of 30. Okay, because I've only got a component of it going downwards. Okay, now from there, I can again use some exact values and solve. So I've got it's mg times root 3 over 2. And I'm going to divide by root 3 over 2 and divide by 9.8 is going to give me a mass of 0.589 ... which is about 0.59 kilograms if I want to round it, okay? Now, obviously, I'm going to use the mass in part B a little bit, so obviously I'll keep my exact value in my calculator ready to go. Now, part B wants to know what's the acceleration. Now, it did tell me it was sliding down, which means it's going to be accelerating down the slope, okay? So the only other option we can do now is to resolve parallel to slope. Okay, which means there's no forces pulling me up the slope. The only force coming down is a component of my mass, which would be mg sine of 30. Should be ma, so ma. Okay, now you'll notice both of these functions have the mass, so the mass isn't actually relevant for me here, so I can cross them off. Okay, the next thing I can do is sine 30. Okay, if we look at what we had up before, okay, let's remember what sine 30 is. Sine 30 is a half, so that means a half of g equals a, and g is 9.8 as we know, so a must be 4.9 and then meters per second squared. Okay, so think about when you've got an inclined plane, you've got to think about resolving either perpendicular or parallel. So, for the next one, okay, there's quite a lot to do in this question 3. I've got a box of mass 5 kilograms rest on a rough horizontal table and is connected by a light and extensible string with a metal sphere of A of 2 kilograms. The string passes over a smooth, fixed pulley at the edge of the table, and A hangs vertically downwards as shown in the diagram. Okay, the string between B and the pulley is horizontal, and the coefficient of friction between B and the table is 0.35. The system is released from rest with the strings taut. Okay, so if I let this go, I want to know what the acceleration is and the tension. If I let this go, I got to think about what's going to happen. The only forces really working are going to be the tensions in the string. So B is going to have to move to the right and A is going to have to move down. But before I do that, let's put some forces on my diagram. So I've got 5G going there. Going up, I'm going to have R. I'm going to have tension in the string. Now, because it's light and inextensible, it means that both the tensions are the same. Now, with A, I'm going to have 2G going down. And as we said, A is going to have to be moving down, so it's going to have to have acceleration that way, and B is going to have to move to the right. Now, I am missing friction. Okay, now if it is going to move to the right, that means friction works in the opposite direction. So this would be my F max, okay, which we know is mu R. Okay, so to find the acceleration and the tension, okay, I need to think about looking at the forces around each of the points. So either I look at A or I look at B. So what I'm going to do first, okay, is I can find R really easily. Okay, I can resolve vertically at B. Okay, so if I resolve vertically, and I'm going to say where I'm resolving vertically, so at B, going up initially equal what's going down. So R will equal 5G. Okay, that now allows me to find F max because I know what the coefficient of friction is. So I'm going to say using F max is mu R. Okay, F max must be 0.35 times 5G. Okay, which is the same as 1.75 G. Now you notice if you've times by G, that's fine. Okay, it can just make a little bit more of an awkward decimal for you to work with. So sometimes it is easier to leave G in your answer. Okay, as much as you can. So I now know what R is. Okay, now I've only got two other things to do. I can either resolve horizontally at B or I can resolve horizontally at A. Now, if you look at both of these, both of them have two unknowns. They both have an A and they both have a T involved. So again, I'm going to have a similar scenario that I've had before, where I'm going to have to do some simultaneous equations. Let's firstly resolve, since we're already working with B, let's carry on with B. Let's do horizontally at B. Okay, and we're going to take direction it's going to move as positive, so that's to the right. Okay, so going to the right, okay, I've got T. Going to the left, I've got F max, which is 1.75 G. Okay, then that's going to equal MA, which would be 5A. So that's equation 1. Now let's do resolve vertically at A, because I can only do one thing at A. There's no forces happening horizontally. So that means going down would be my positive, that's where I'm going to move. So going down, I've got 2G. Going up, I've got T, and now that gives me 2A. There's the second equation. Now, again, the coefficient of T, one's a 1, one's a -1, so I can get rid of them by adding the two things together. So I'm going to do 1 plus 2 in this case, because I'm thinking of my negative numbers here. Okay. If I do minus 1.75 plus 2, that's going to give me 0.25G. Then I'm going to have 7A, and I can solve that for A. Okay, so I've got 0.25 times 9.8, and then I'm going to divide by 7, gives me 0.35 meters per second squared. So that's the first answer that I wanted. Okay, the second answer, it wants the tension in the string. Okay, now again, all I'm going to do is I'm going to substitute into them. So let's sub it into 1. Okay, if I substitute it in, we should get a tension out as 18.9 newtons. Okay, so make sure your algebra is pretty smooth with that. Okay, but apart from that, that is both answers. So this would be part 1. This would be part 2. Okay, now quite often this is all part of one question where it says find the acceleration and the tension, and it's all in one question. So just be careful of that. So the final question, okay, quite a tricky one, this one, is this one here. So I've got a diagram, so it's friction and it's inclined planes, okay, but also I've got a car and a trailer connected, which makes things a little bit more awkward for us to deal with, okay? So I've got the diagram shows a car which is mass of 1,500 kilograms is connected by a trailer of mass 600 kilograms by a mean of a light rigid tow bar, okay? So obviously there's going to be some sort of tension in that tow bar as the car pulls. The car is moving upwards along an inclined slope of alpha, where sine alpha is 7/25. A constant resistance of 300 newtons acts on the trailer, and then the car. Sorry, I missed the line. The constant magnitude of 400 on the car, and then 300 on the trailer. The car's engine is making a forward force of 8,400. Okay. So what we need to do is I'm going to first just draw a really generic diagram and think about where we're going to tackle it from there. So if I look at what's happening at the moment, let me draw a bit of a big diagram here. I've got a trailer, I've got the car, let's put some, that's alpha. I've got the trailer is 300, so it's 300G going down. Here I've got the car, which would be 1,500G. Obviously they both have a normal reaction going up, but we don't necessarily know what friction is, that's not that important to me. Going up is the drive from the car. Going down, I've got the resistance to the trailer, which we said was 300. The resistance to the trailer, which is 400. Now here's the weird bit, okay? We've got tension in this rod in between, because I'm pulling it up, okay? Which means I've got tension going this way, and I've got tension going this way, okay? So we got to consider with these kind of things. Am I going to look at the whole system, so everything combined into one, or I'm going to look at just the trailer or just the car? Okay. Now again, it is going upwards, so it's going to be accelerating upwards. Okay. So for part A, I want to find the acceleration. Okay. So what I'm going to do for part A is I'm going to consider the whole thing together. Okay, like it was one unit, because if I do that, these tensions are going to cancel each other out. Because going up, I've got tension, and going down, I've got the same tension. Okay, so those two are going to cancel each other out. So what I can do is one big block. Okay, I'm also going to write sine alpha is 7/25 here to help me. Okay, so overall, they've got a weight of 1,008. Of that should be 600, shouldn't it? There you go. Of 2,100. Okay. Going up, I've got the 8,400 that's driving the car. Going down, I've got the 300 and the 400. That's 700 going down. And I've got my acceleration going up. Okay, so if I want the acceleration, I'm going to resolve parallel here. Okay, so that means everything going up minus things go down is ma, so I'm going to use Newton's second law. So going up, I've got 8,400. Going down, I've got the 700. And I've got the component of the mass. So I've got 2,100 g sine alpha, which is good because I already know what sine alpha is. And that should be ma, so 2,100. Don't want to do that. Let me go across a little bit. There you go. A. I'm going to solve this, okay? So, again, I know what sine alpha is, okay? So I can plug it in. It's 7/25, which means I can put everything in this left-hand side into my calculator. It gives me 1937.6 is 2,100 A. Okay, and then I can solve that for A by dividing by 2,100. Gives me not a nice fraction, but I'll write it down as a fraction first, okay? Again, because I'll probably need it in a moment. But as a decimal, it's 0. What's on corrected 3 decimal places, 0.923 meters a second squared. Okay, so I looked at the whole system for this one. Now for part B, determine the tension. Okay, for this one, okay, I now need to split it up, because like I said, when I looked at the whole system, the two tensions cancel each other out because I had one going up and one going down. So I need to either look at just the trailer or I'm going to look just the car. Now I know more about the car, so I'm going to look at just the car. Okay, so let's look at the car as it is. Okay, I've got 1,500 G going down. I've got the 8,400 going up. Going down, I've got the 400 newtons, which is pulling it down, and I've got the tension pulling it down. Again, I've still got my R going up, but I don't need that, okay? So I'm going to resolve parallel again, okay, because tension is working parallel. So resolve parallel to plane. And I'm going to jump into it. So going up, I've got 8,400. Again, I'm going to work in a direction that's accelerating, which is up the slope. Down, I've got 400. I've got the tension, and I've got the 1,500 G sine theta. So sine alpha is 1,500 A, which I know is 346/375, which isn't going to be a nice number. Okay. So if I tidy up this left-hand side, the only thing I don't know is t, so let me leave the minus t. Everything else I can type in my calculator, because I know sine alpha is 7/25. Okay, so if I type everything in, I get 3,884, and then on this side, I still got 1,500 times 346/375. Okay, which I'm pretty sure will give me a really nice number out. So now from there, all I'm going to do is solve for tension. So I'm going to do 3,884 minus this right-hand side gives me 2,500 newtons exactly. Okay, so for that last one's really tricky because you have to decide whether you want to look at the full system or if you just want to look at the trailer or the car. Now, again, if you looked at the trailer in a similar kind of manner, you should have ended up with the same answer. Okay, the tension should be balanced and should be the same. Okay, so apart from that, year 13, you should have, again, had your action points, and then you should have had one of these videos for you to go and watch. So can you please go and do that now, make your notes, and complete any task as well, okay? But apart from that, okay, really, really well done. Okay, there's some really, really difficult questions, okay, in this. Go back through if you need to copy any of the answers down. Apart from that, I'll see you in the next video. Okay, guys? Thank you.